Okay, so let me introduce the first speaker. This morning, it's going to be JOERG Schneider, who's going to talk about some of the Kasimovian continental basins of Europe and the mixed marine, non-marine Kasimovian basins of North America. So with that, JOERG.
View of Kasimovian continental basins of Europe and mixed continental marine basins of North America. It's not big science, just an overview to give you an idea on the non-marine Kasimovian. Next. The Kasimovian world of Euromerica. Euromerica was situated in the paleotropical belt of Laurentia. Climate was seasonal with pronounced wet phases, of course, modulated by the paleogeography. In Europe, after the last marine aggressions during the Moscovian, we get outspreading continental climate, of course, still wet. In North America, the maritime print of the climate lasted up into the Permian. The influence of paleotopography on climate distribution and on climate and precipitation distribution in Europe was only insignificant because the Rosscoe mountains were already cut down to low mountain ranges. The opposite may become true from North America because of the ancestral Rocky Mountain orogeny, which may produce really high mountain ranges. Next. In a global view, the Kasimovian looks a bit boring. Next. And even if we look on the basins especially in Europe, but partially in North America too, we have more gaps than continental sediments. You see this red frame. Next. Anyway, the Kasimovian deposits play an important role for the calibration of the non-marine biostratigraphic zonations, contours, stars, insects, tetrapods, macroflorals, and so on, because of co-occurrences in the mixed marine basins of North America. Next. Yeah. There, I will go in more detail later, especially the Atrasado formation, which is mixed marine continental, delivers us many Conodont ages for the calibration of the non-marine index fossils. The newest paper of Rosscoe and Barrick from 2021, and watch the talk of Stanislav Opluštil on the macroflorals. Next, please. Yeah. Let us go to some examples from different parts of the world. We start with Czech Republic. Next, the red spot. There in the Czech Republic, we have a lot of Carboniferous basins, which are exceptionally well investigated. Because of former coal mining and still existing well cores from coal exploration. And the Czech team, led by Opluštil, made a good job, and you could read about this in many, many publications. But again, you see this in the blue frame, this gap in the Czech basins during the Kasimovian, which may be caused by a tectonical event. Next. There's one of the nice, still existing surface outcrops. The northern part of the Pilsen Basin, the Nearshani member of the Kasimovian Plateau Formation. Exposed is a proximal part of a broad paleotropical alluvial plain with fluid sandstone conglomerates and this reddish stuff intercalated floodplain deposits. This pass over in the direction to the basin center in gray facies with coal seams and backshales of lakes, which form there the famous Nearshiny fossil Lagerstätte, well known to, especially to vertebrate paleontologists. Next. Leuker 2016 has investigated in much detail these deposits, the typical facies architectures of a perennial gravel bed brided fluvial system with intercalated red beds of the floodplains with typical Celtic soils. Next. Yeah, these check basins deliver us good possibilities for calibration of zonations, especially because of this huge amount of radioisotopic ages as shown here, which could also be used for interregional correlations across Europe to the east, to the Donetsk Basin and the Appalachian Basin in the west. Next. Yeah. The red dots in the insect zonations are based to a large part on check base. Next. Yeah. Now in Germany, next. In Germany, we have the Kasimovian, Duisburg, and Gettelborn formation, which are only known from former coal mining, for the success. And we have some small outcrops of the Gorensen formation in East Germany in the Saale Basin. The red spot marks the well Querfurt from 1964, beautiful drilling course, lithofacially very similar to that what we have seen in the Czech Kladno formation, cross-clastic fan deposits in red bed facies, floodplain deposits which change over, pass over to the gray facies of the basin center with coals and lacustrine black shales. Next. Kasimovian shale transitional sediments are well exposed at the Saale River, the name-giving river for the basin, near Hellertown, alluvial bright plain of perennial rivers with typical wet beds, and paleosols, calcisols, rhyzolites of a seasonal climate. Again, in the basin center, lacustrine black shales and coals in the depositional centers. Next. Now we are going to France. Next. There, at the southern border of the massive central, we have the area of the Lodève Basin, well dated isotopically, the sediments. Next. And there, close to the lovely small village Kasimovian at the slopes, there are still the outcrops of former coal mines in the Kasimovian Basin, the upper part, several hundred meters upper part of the section right above. Next. These are again alluvial plain deposits with mainly with sandstones and fine clastics of the floodplains and beautiful intercalated coal seams. White and yellow lines in the coal seams left bottom. These are volcanic ashes, different kinds of paleosoils, and a beautiful 1 to 2 meter thick ashfall lower right with in situ buried plant remains. Next. Yeah. Now we go to North Africa, Morocco. Next. There in the western high Atlas Mountains, we have the Zeus Basin containing up to 1,800 meters of Kasimovian sediments. Next. There are typical outcrop pictures, especially of the upper 400 meter of those section, which is very fossiliferous near the Tinajas village in the Quetzalcoatl Canyon. Next. These are mainly low gradient distal fluvial brightvein deposits, no conglomerates, nearly nothing, of course stuff, deposited in a system of braided and anastomosing rivers, intercalated here in gray and black on the slide, are pond and lake deposits which are very fossiliferous. Next. This in the thin section, lacustrine rhyolites indicate a seasonal climate with annual rain and drought periods. The facies architectures, sediment color, and soil types point on a very high groundwater level and additionally on high sedimentation rates. On the left bottom, load casts are very common, pointing on event sedimentation. Next. Now, the flora is dominated by conifers and other mesophilous to xerophilous elements, but also microphilous elements occur. Interestingly, we have in the Kasimovian already widespread Barrican conifers and Dichophyllum muri occur, which is known otherwise from the early Permian of North America. Common are plateauid insects, especially the xeromorphous Opsumilacus. We have increasingly a good record of tetrapod tracks and the first amphibian skeletons too. Next. Yeah, now to North America. Next. There in the steppe-like landscape of New Mexico, the Kasimovian Atrasado formation is very well exposed, especially the mixed marine Tinajas member of Kasimovian age. Next. These deposits are excellently exposed in the Kinney Brick Quarry in the Manzanita Mountains, not so far from Albuquerque. There we have a 30 centimeter zigzag succession of marine limestones at the bottom, followed by brackish marine siltstone and fluvial sandstone on the top of the picture. This is a very famous conserved Lagerstätte for late Pennsylvanian marine and non-marine biota, singular for this time size, not only for North America. Next. Yeah. 3 meters below the floor of the Kinney Brick Quarry, a fusillinate rackstone has been poured, which gives us a record of the marine guide fossils. It is followed by 5 to 10 meters of Dunbarella shales, brackish marine laminated siltstone with mass occurrences of the name-giving brackish marine bivalve Dunbarella. Shales contain a well-preserved diverse macroflora just now described by Bill DeMichael and Donovan. Common are terrestrial animals, fortunately, mainly insects, some millipedes, rare arachnids, and some amphibians. Next. Typical for this Dunbarella shales is a well-expressed lamination consisting of 0.5 to 2 centimeter thick major laminae, which are subdivided by a very fine subordinate lamination shown here by the whitish lines, or in the thin section by these squares. The depositional environment of these laminated mudstones is now interpreted as tidally modulated bifill succession. Seasonal river floods transported the clastics into these environments, and the tidal influence decelerated and accelerated the river currents and the associated sediment plumb, as shown in the reconstruction of the depositional environment to the right. Next. The fossil content is really exceptional. There's a fish bed, bed number 3, which contain a very rich and diverse brackish marine to marine fish fauna, as well as, but rare, freshwater amphibians. You see some examples of the exceptional well-preserved flora and one of my lovely cockroaches. Next. Yeah. The Tinajas member is a very important level for calibration of known marine fossils with the standard global chronostratigraphic scale. Left above, you see the zone fossils, the insect zone fossils, which could be well correlated by Conodont and of the Idioconodontus contraris zone to the Middle Kasimovian, early to Middle Kasimovian, the work of Barrick and Rosscoe. Next. And now a jump to the east, Russia and the Ukraine. Next. There in the Donetsk basin of the former Carboniferous quarry is one of the nice outcrops with marine limestone and fossil-rich alluvial plain deposits. It's a really trading play, future play for known marine correlation. Next. We have these beautiful cockroaches, well suited for known marine biostratigraphy together with fusselinids in the limestone, which indicate as a Middle Kasimovian age. Okay, next. This was it. We thank the members of the known marine correlation working group, as well as many colleagues from the regions discussing this talk, which support us with data and pictures. Next. And a special, very special thanks to the Czech Carboniferous Mafia for all the valuable radioisotopic ages which we need for known marine correlation. Thank you. I'm over. And hopefully in time.
Okay, well, thank you, JOERG. Let's see, are there any questions? I guess we're about 2 minutes early here, so we have 12 minutes for questions. Okay, so I don't see any questions in the chat, so let me start. Let me break the ice. JOERG, if you look at these different basins from the Ukraine to New Mexico, okay, across this broad stretch of Kasimovian Pangea, can you say something, can you make some generalizations about changes in sedimentation pattern, say across the Moscovian Kasimovian boundary? Is there some direct, thing you can say about that over that huge region, or is everything very diachronous and subject to local?
Could you show again the figure, wait, 11, slide 11. Interestingly, it comes out by especially by the isotopic age datation made by the Czech colleagues. If you look on this picture and the Kasimovian frame, starting in the late Moscovian, we appear first wet red beds in Europe, and they increase. We have to keep in mind that we have a strong post-Carboniferous erosion in several basins, but also, and the same we could see in the Appalachian Basin. There is a major climate change possibly at the end of the Moscovian. Yesterday we talked about the disappearance or the restricted occurrence of lycopods that died not out completely. They because of the restricted large foredips, especially in Europe, with the marine incursions, their environment disappears simply by the end of the Moscovian. Yeah, and we have this, obviously, we have this gap in sedimentation and erosion, which may be really, especially in the type area of the various sites in Europe, indicate a tectonic event, far-reaching tectonic event. It's not a mountain forming event, but possibly a regional to interregional uplift.
Okay, good, thank you. So Ron Martino has a question. So Ron, you should turn on your video and audio, please.
Yes, you obviously tried to cover a lot of basins in a very short period of time, and it has provided a good bit of perspective. I was curious, in your lacustrine limestones, what kind of relationship is there in any cycles to the paleosoils? Do you see the lacustrine limestones capping, these red bed paleosoils that you have in these various basins?
Yeah, I have observed from the Donetsk Basin in Russia and the Ukraine, across Europe, that we have in Kasimovian, starting in Kasimovian, especially starting at the Kasimovian times, we have the occurrence of this not really very thick lacustrine limestone. These are grayish micrits containing algas, characene algas, and often very common small gastropods. They are widespread. They appear in biorestricted subsidence during in the top of fining up cycles. These fining up cycles may be caused mainly tectonical. It's in Europe, it is hard to see there any cyclicity, extrinsic cyclicity. It is mainly tectonical governed. But again, this kind of limestones, decimeter thick only, appear every time together with calcic soils, with common calcic soils during downslowing sedimentation. If sedimentation starts to become quiet, then of course you get beautiful calcic soils and you get these lacustrine limestones. For vertebrate palindoges, they are really very interesting. They contain micro remains of vertebrates which are not known from the black shales, lacustrine black shales of the same time, a completely unknown vertebrate fauna. Must be published.
All right. Okay. Now we have John Knight has a question. John, can you turn on your video and audio, please?
Am I in yet?
You're here.
Okay.
I see.
I can't see myself, of course. Thanks, Jörg. That's very interesting. And thank you for leaving that particular slide up for us to see. Because, of course, part of the interest that some of you will remember from the era of my mentor, Bob Wagner, and others, is that, of course, that block of time that we see there is occupied, in our belief at least, in northern Spain, by a mixed succession of continental and marine deposits, essentially through the Kasimovian. We do have, as I'll hopefully mention tomorrow, now quite a number of radiometric dates. That isn't the point of this question. Here, it's more the impact of the Veriscan orogeny. You know, we're all looking at this as sedimentologists, but this is the period that coincides with possibly the most intense orogenic deformational episode in the formation of the Etruscan belt. Certainly in northern Spain, we would be expecting, I would identify this as the tightening of the Cantabro-Asturian orocline. Certainly a large number of major thrusting episodes and significant uplift and a mountain chain. So the basins of northwest Spain we see as being peripheral to Paleotethys, that is, using modern terminology, will be on the south side of that mountain chain. We have a significant sort of barrier between the floras and faunas of that southern side, the Paleotethys area, in any comparison with the basins either on the northern side, the northwestern side, let's say the on the American continental area as we know it now, and significantly those basins that are within the Etruscan sort of mountain barrier. Now, so my question is that you've given us an overview of a lot of basins, some of which would appear to be on the south side, like the North African ones, and comparison with those that are either within the Etruscan chain or on the north side. So one question is, are you able to sort of recognize any difference, any impact of this barrier, either climatically or in any of the other physical parameters that affect sedimentation? And I should stop there, but I would also add, as a supplementary later, where are the volcanoes? That's you know, there's so much volcanicity. There is a question as to you know, I have some suggestions, but there's another question there of you know, are we dealing with convergent margins? This is explosive volcanicity. Where are the volcanoes? Sorry to have gone on so long. I'll stop there.
Quickly, John. I have been together with Bob Wagner in the Cantabrian Mountains several 10 years ago. So I don't not really well know the Cantabrian area, and unfortunately for me, known marine animals, conchostons, insects are more or less unknown from there. Much better informed in this area is, of course, the Czech working group around Opluštil. Anyway, concerning tectonic events, yes. If we look, for example, in the Sarnar Basin, based on the qualification rank, they assume an erosion of 3,000 to 4,000 meter Moscovian sediments before the Kasimovian or inside the Kasimovian. And as you see from the correlation of the basins, Czech basins with other basins, we have this erosional gap also in several other basins. Anything happens. Minimally, an uplift, maybe of several hundred meters, which we could observe in the worst sites, possibly much stronger in the inner worst sides of the Moldanubian area of Czech. Additionally, we see this increasing appearance of red beds. So it may be an interference of tectonics and climate. Red beds start, sedimentation of wet red beds start already in the late Moscovian, but get pronounced in the Kasimovian. So most possibly an interference of tectonics and climate.
Jorg, I'm going to have to end the discussion here. Yeah. We've already gotten to tectonics and climate. We need Eustace. We'll have more to talk about.
Yeah.
Let me say one thing about this diagram. This is from a recent paper by Opluštil et al. That the GS of London just published. It's an extremely important paper on macrofloral biostratigraphy. I'm hoping Stan will upload it to the Dropbox so that you can all, because these diagrams are very detailed and they merit close study. So thank you, JOERG. Thank you, questioners. Let's move on to the next speaker.